Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through area. Now, because there are so many shapes that you need to know, and by the way, none of them are new shapes, you would have already learned them in years 7 to 9, I'm not going to go through every single shape. I'm just going to go through sort of the ones that I think are the difficult ones and also composite shapes. So all the formula have been given to you on the slides, in the notes, so you don't need to worry about that. So, for some reason, and I'm never 100% sure why, the area of a trapezium seems to cause a lot of difficulty. So let's look at an example of that. So firstly, you need to know what a trapezium is. So a trapezium is a quadrilateral, meaning it has 4 sides, and one of those pairs of sides is parallel. So it's not a parallelogram because that has 2 pairs of parallel sides. But clearly this side here and this side here, they're not parallel. So one pair of parallel sides makes this shape a trapezium. So the formula for the area of a trapezium is H. Now, whenever we say H in formula for area, volume, surface area, it always means perpendicular height, not slant height. So H is going to be this height here. You divide the height by 2 and you times it by the sum of the 2 parallel sides. So A and B are the 2 parallel sides. It doesn't matter which way around you name them, which you call A and which you call B. So let's look at an example. So I'll draw a trapezium like this. Okay, now note, this is still a trapezium because it has only one pair of parallel sides, even though it's got some right angles. It's clearly not a rectangle because it won't have 4 right angles. It only has 2 right angles. So let's say that I'm going to call this one, say, 15. Let's say this one's 12, and we'll call this one 18 and 27. Okay, so I'm going to find the area of this shape. So don't deviate from the formula. It's perpendicular height. 12 is the perpendicular height because of this right angle there. Divided by 2 times the sum of the 2 parallel sides, okay? So this 15 is the slant height. We'd need it if we were asked about perimeter, but we weren't asked about perimeter. We're just asked about area. So it's just 6 times 45, which is 270, and it's units squared. Okay, that's how you do the area of a trapezium. Please pause and copy this down. I'm now going to show you area of a sector. So a sector is like part of a circle. It's like a pie cut out of a circle. So I might have something like this, and I want to find its area. So what I need to know is I need to know this length here, and I need to know the angle in the middle. So let's say, for example, that this angle was 30 degrees and this here was like 8 centimeters, okay? Now, because this is part of a circle, if this is 8, this will also be 8 because the radius of a circle is the same no matter where you start. So this would be the center of a circle. So the idea behind the area of a sector is, and I'm sorry about my poor drawing, but it's you find the area of the whole circle and you account for the fraction of a circle you have. So, how would I find the area of a whole circle with radius 8? Well, the area of a circle is pi r squared, okay? So make sure you know that formula. So I'm just going to do, in this case, pi times radius squared. How easy is that? Now I've got to figure out what fraction of a circle do I have. Do I have, 1/3? Do I have 1/10 or whatever? Well, we can figure that out from the angle. That's why we need the angle. There are 360 degrees in a full circle. So what you do is you take that angle, I'll call it theta, divide it by 360. That's the fraction of a circle you have. For example, in this case, I have 33/360ths of a circle, or 1/12. This sector I drew in blue is 1/12 of a circle. So I find the area of the whole circle and times by 1/12. Pretty easy, isn't it? So now I'm just going to put this on my calculator. And if you do that correctly, you can put it all on your calculator in one go. The answer you get should be about 16.76. I rounded it to 2 decimal places, okay? How easy is that? Now we're just going to take a look at composite shapes. So when you're finding the area of composite shapes, you'll either have 2 or more shapes stuck together, in which case you just find the area of each one and add them together. Or you will have a situation where you have 1 or more shapes cut out of another shape, in which case you do the same but minus. So let's look at the shape in blue. It's a weird shape. It's a kite plus a semicircle. So how do we find the area of a kite? So you need to know this formula. So the area of a kite, you actually multiply together the 2 diagonals and divide by 2. Now you might be thinking, well, hey, wait a minute, the 16-meter line and the 12-meter line, they're perfectly, one's vertical, one's horizontal. They're not diagonal. Well, in maths, diagonal has a specific meaning. It's just a line that joins non-adjacent vertices. So the 16 and the 12-meter line, even though they're not leaning diagonally, they're called diagonals. So area of a kite, multiply the 2 diagonals together, divide by 2, so this would just be 96 meters squared. Now we need to find the area of the semicircle. Now to find the area of the semicircle, you need to know the radius, but we aren't actually told it here. But the property of kites is that the diagonals bisect each other, so they cut each other in half, and they do at right angles. So what I have here is a right-angled triangle. And we've already learned Pythagoras. Sometimes when you're finding area, surface area, or volume, you'll need to find an unknown length using Pythagoras. So I'm going to call this one x. So what I have is a triangle. So this side here is half of 16, the other side is half of 12, and I find x using Pythagoras. So x is the longest side, so remember you add in that. So this is going to be square root of 8 squared plus 6 squared, which is 10 meters. So 10 meters is not the radius of the semicircle, it's the diameter. If the diameter is 10, the radius will be 5. So the area of the semicircle will be pi times radius squared, but here you need to divide by 2 because it's half a circle. You don't normally divide by 2 for circles. The only shapes you divide by 2 for normally are trapezium, kite, and triangle. But we divide by 2 in this case merely because it is half a circle. So if you put that on your calculator, you get about 39.27. So therefore the total area will just be the 2 areas added up, which gives us about 135.27 meters squared. So that's when you have 2 shapes added together. Let's now look at one where you have one shape cut out of another. So for the second shape, we're going to find the area that is shaded red. So what we have is a parallelogram with a triangle cut out of it. So it's a very similar process. We're going to find the area of the parallelogram and find the area of the triangle, but this time we're going to subtract because the triangle hasn't been added to the parallelogram, it's been taken away. So we're finding the area shaded in red. So the area of the parallelogram, it's important you know that this is a parallelogram because it has 2 pairs of parallel sides. I don't know why people always seem to mix up when to use parallelogram, when to use trapezium. This is a parallelogram, so we use the formula base times h. H always means perpendicular height. So the area of the parallelogram is 12 times 8 or 96 meters squared. The area of the triangle, you times the base by the perpendicular height but divide by 2. So the area of the triangle is the same as the area of the parallelogram, the same formula, except you divide by 2. People, for whatever reason, always forget to divide by 2 when finding the area of a triangle. So 5 times 3 divided by 2 is just 7.5 meters squared. So the total area is just parallelogram minus the area of the triangle, and that just leaves you with 88.5 meters squared, and we're done. The final thing I need to go through is converting square units. So most people have absolutely no problem converting units of length because they know that, 10 millimeters in a centimeter, 100 centimeters in a meter, 1,000 meters in a kilometer, and so on. So the thing that people mess up when they do mess up those calculations is getting the divide and times wrong. So if you're going from a unit of measurement that's smaller to one that's larger, what you have to do is divide because there are fewer of the large units. There's fewer kilometers than meters. So to go from meters to kilometers, I divide. On the other hand, if I go from a larger unit to a smaller unit, I times. And that's because there are more of the smaller unit. So if I'm going centimeters to millimeters, I times because there are more millimeters than centimeters. So that's pretty self-explanatory, but people have trouble when it comes to converting square units. So let's look at an example. Let's just say I draw a square. So this is supposed to be a square. And let's say it has side length of 1 centimeter. So it's 1 centimeter by 1 centimeter. So you know how to find the area of a square, just 1 times 1, and that would give you 1 centimeter squared. Okay, nothing groundbreaking. But 1 centimeter is 10 millimeters. So this square is 10 millimeters across by 10 millimeters down. So if I want to find its area in millimeters squared, it's 10 by 10, which is 100 millimeters squared. So there are 10 millimeters in a centimeter, but there are 10 squared, i.e. 100 square millimeters in a square centimeter. So when you're converting square units, it's almost the same, but you have to square the conversion factor. So all of these get a squared on them. So for example, if I had, say, 5 kilometers squared, that's not 5,000 meters squared. It would be 5 times 1,000 squared, or 5 million meters squared. So there's 5,000 meters in 5 kilometers, but there are 5 million meters squared in a kilometer squared. I had to square the conversion factor here because we're talking square units. All right, hopefully this hasn't been an information overload. This has been the luckiest maths teacher in the world. Have a great day.